a problem from continuity and uniform continuity of a function. And the problem is, let fx, this is sin x, and gx, this is x square. Then 4 options are given. We have to choose the correct alternative. Okay. To solve this problem, we first see what is the definition of uniform continuity. And we write here UC in the short form of uniform continuous function or uniform continuity. And the definition of uniform continuity of a function fx is that for any pre-assigned epsilon greater than 0, there also exists a positive number delta or positive real number delta such that mod of f of x1 minus f of x2 less than epsilon whenever the difference between 2 points x1 and x2 less than delta. This is the definition of uniform continuity. Okay, and we know that if a function is uniform continuous in a certain interval of r, then it must be continuous at every point of this interval. Okay, we use these two conditions to solve this problem. We first take x1 and x2 be two real number with the property that x1 minus x2 less than delta, where delta greater than 0. Okay. Now for the first problem, if we write f of x1 minus f of x2 and this mod, this is given by mod of sin x1 minus sin x2, and this is 2 into mod of sin x1 minus x2 by 2 into cos of x1 plus x2 by 2. Okay, this is the formula of sin c minus sin t. This is 2 into sin of c minus d by 2 into cos of c plus d by 2. Okay, and we know that the maximum value of cos or sin is 1. So we can write this term as 2 into mod of, this is sin x1 minus x2 by 2. Okay, because this is 1. And we know that if this x1 minus x2 is very small, then we expand sin x in the series expansion x minus x cube by factorial 3 and x to the power 5 by factorial 5 and so on. Okay, so we can write here for small value of x, sin x less equal to x. From here we get this is less equal to 2 into mod of x1 minus x2 by 2, because this is less equal to this. Okay, and cancel out 2 2, we get the result as this is mod of x1 minus x2. Now since mod of x1 minus x2 less than delta, so we put here less than delta and choose the delta is equal to epsilon, which is pre-assigned. Okay, so we get this is less than epsilon whenever this is less than delta. So it must be uniform continuous. Okay, now for the second function, if we take g of x1 minus g of x2, and clearly this is mod of x1 square minus x2 square, and this is mod of x1 minus x2 into x1 plus x2. Now if we put this relation here, we get this is less equal to delta into mod of x1 plus x2. But we cannot make it is less than epsilon because of the presence of this term mod of x1 plus x2. Okay, because we know that for any two value x1 x2, the minus and difference is less than delta, but this may be not less than delta or not be so small. Okay, if we take two positive number or two negative number, then the difference of two positive number and two negative number, if these two number are very large, but if these two number are nearly equal, then the mod is less than delta. This is very small. But the sum of these two number may be not very small, it may be larger than in number. Okay, so we cannot make this is small. Okay, so we cannot write this is less than epsilon, and we say that this function, that is g, is not uniformly continuous. Okay, but we know that gx is a polynomial function, so it must be a continuous function. So our answer is fx and gx both are continuous, but the first one is uniform continuous and second one is not uniform continuous. Now we check the option. Okay, both f and g are uniform continuous. This is not correct. Here f is uniform continuous but g is not uniform continuous, so this is correct option. Okay, and this is very important type of problem of continuity and uniform continuity. Okay, thank you and keep watching Math A to Z.